Hey there, science fans. Today we're diving into the fascinating world of electromagnetic interference, or EMI for short. Now, you might not be able to see it, but trust me, EMI is all around us. It's like an invisible symphony of electrical signals, some harmonious, some not so much. Think about it. Our smartphones, Wi-Fi routers, Bluetooth headphones, they all emit electromagnetic waves. And while these waves are essential for our modern lives, they can sometimes clash, creating unwanted interference. This interference can disrupt our electronic devices, leading to all sorts of headaches. Imagine your favorite song getting interrupted by static on the radio, or your TV screen suddenly displaying fuzzy images. That's EMI in action, folks. And it's not just annoying, it can have serious consequences in critical applications like medical equipment or aircraft navigation systems. So, join me as we explore the causes and effects of EMI and most importantly the ingenious techniques engineers have developed to mitigate this invisible menace. Get ready to become an EMI expert. Remember those old radios that used to crackle with static whenever a car drove by? That, my friends, was EMI at work. It's like trying to have a conversation at a rock concert. All those competing sounds make it hard to hear anything clearly. EMI happens when electromagnetic waves from one source interfere with the signals of another. This interference can be caused by a variety of sources, from natural phenomena like lightning strikes to man-made devices like power lines and motors. But the real culprit in our modern world is the proliferation of electronic devices. Every time you turn on your smartphone, laptop, or even your microwave, you're adding to the electromagnetic soup that surrounds us. And as we pack more and more electronics into our lives, the potential for EMI only grows stronger. The consequences of EMI can range from mildly annoying to downright dangerous. In some cases, it might just cause a bit of static on your TV, or make your Wi-Fi connection drop out. But in other cases, it can interfere with critical equipment, leading to malfunctions, data loss, or even accidents. That's why it's so important to understand EMI and the techniques we can use to mitigate its effects. By reducing EMI, we can ensure that our electronic devices operate reliably and safely, without interfering with each other or with the world around us. So how do we combat this invisible enemy? Well, fear not, science enthusiasts, because engineers have developed a whole arsenal of techniques to mitigate EMI. It's like a game of electromagnetic chess, where we use clever strategies to outmaneuver the interference. One common approach is filtering. Imagine a bouncer at a nightclub only allowing the right frequencies to pass through while blocking the unwanted ones. That's what EMI filters do. They act as gatekeepers, separating the desired signals from the interfering noise. Another technique is shielding, which is like building a fortress around our electronic devices to protect them from external electromagnetic waves. Just like a medieval castle with thick stone walls, shielding materials can block or absorb EMI, preventing it from reaching sensitive components. We can also tackle EMI at its source by using techniques like soft switching and random modulation. These methods involve altering the way electronic devices generate electromagnetic waves, making them less likely to interfere with other devices. And for those really tough EMI challenges, we can even harness the power of chaos theory with techniques like chaotic pulse width modulation. It's like introducing a bit of controlled randomness to disrupt the regular patterns of EMI, making it less effective. Each of these techniques has its own strengths and weaknesses, and the best approach often involves a combination of methods tailored to the specific application. But by understanding the principles of EMI mitigation, we can create a world where our electronic devices coexist harmoniously, free from the tyranny of interference. Let's start our deep dive into EMI mitigation with one of the most common and effective techniques: passive EMI filters. Think of these filters as the guardians of the electromagnetic spectrum, carefully separating the desired signals from the unwanted noise. Passive filters are like electronic traffic cops, directing the flow of electromagnetic energy. They consist of passive components like capacitors and inductors, which store and release energy in a way that selectively blocks certain frequencies while allowing others to pass through. Capacitors, for example, act like high-frequency short circuits, allowing high-frequency signals to pass through while blocking low-frequency ones. Inductors, on the other hand, act like low-frequency short circuits, allowing low-frequency signals to pass through while blocking high-frequency ones. By combining capacitors and inductors in different configurations, engineers can create filters with specific frequency responses, tailored to the needs of the application. For example, a low-pass filter might be used to block high-frequency noise from entering a sensitive circuit, while a high-pass filter might be used to remove low-frequency hum from an audio signal. Passive filters are relatively simple and inexpensive to implement, making them a popular choice for a wide range of applications. They're like the workhorses of EMI mitigation, quietly and effectively keeping our electronic devices running smoothly. Section 5. Active EMI filters, intelligent noise cancelers. While passive filters are great at blocking specific frequency ranges, sometimes we need a more intelligent approach to EMI mitigation. That's where active EMI filters come in, acting like noise-canceling headphones for our electronic devices. Unlike passive filters, which rely solely on passive components, active filters use active components like operational amplifiers or op-amps to actively cancel out unwanted noise. They work by sensing the incoming EMI and generating an inverted signal that's fed back into the circuit, effectively canceling out the noise. Imagine you're trying to have a conversation in a noisy room, and someone keeps interrupting you. An active EMI filter is like having a friend who listens to the interruption and then whispers the opposite message in your ear, canceling out the noise and allowing you to hear your conversation partner clearly. Active filters are particularly effective at suppressing narrowband noise, such as the interference generated by switching power supplies. They can also adapt to changing noise conditions, making them ideal for environments with dynamic EMI sources. However, active filters are generally more complex and expensive than passive filters, and they require a power source to operate. But for applications where high precision and adaptability are essential, active EMI filters offer a powerful solution for combating electromagnetic interference. Section 6. Chaotic pulse width modulation, introducing chaos to combat interference. Now, let's delve into a fascinating and relatively new approach to EMI mitigation: chaotic pulse width modulation, or chaotic PWM for short. This technique takes a page from chaos theory, using controlled randomness to disrupt the regular patterns of EMI and make it less effective. Traditional PWM techniques use regular pulses of varying widths to control the output of electronic devices. While effective for many applications, these regular patterns can create strong EMI at specific frequencies, much like a dripping faucet creating a rhythmic noise. Chaotic PWM, on the other hand, introduces randomness into the pulse widths, creating a more chaotic and unpredictable output signal. This randomness spreads the EMI across a wider frequency range, reducing its intensity at any given frequency. Think of it like scattering a handful of pebbles on a calm pond. The regular ripples created by each pebble might interfere with each other, creating larger waves in certain areas. But if you throw a handful of sand instead, the ripples become more chaotic and spread out, reducing their overall impact. Chaotic PWM is particularly effective at reducing EMI in applications with switching power supplies, which are notorious for generating electromagnetic noise. By introducing chaos into the switching patterns, we can effectively scramble the EMI, making it less likely to interfere with other electronic devices. Section 7. Comparing the arsenal, choosing the right EMI mitigation strategy. Now that we've explored some of the most common EMI mitigation techniques, you might be wondering, which one is right for my application? Well, the answer, as with most things in engineering, is, it depends. Choosing the right EMI mitigation strategy is like assembling a team of superheroes, each with their own unique powers and weaknesses. You need to consider the specific challenges of your application, the available resources, and the desired level of performance. For example, if you're dealing with a known and constant source of EMI, a simple passive filter might be all you need. But if you're working with a complex system with multiple EMI sources, a more sophisticated approach like active filtering or chaotic PWM might be necessary. Shielding is another effective technique, but it can add bulk and cost to your design. Soft switching and random modulation can reduce EMI at the source, but they might also impact the performance of your device. Ultimately, the best approach often involves a combination of techniques, carefully chosen and implemented to address the specific EMI challenges of your application. It's like a game of electromagnetic chess where you need to anticipate your opponent's moves and develop a winning strategy. Section 8. Best practices. Building an EMI resilient future. As we become increasingly reliant on electronic devices, Mitigating EMI is no longer just a technical challenge. It's essential for ensuring the reliability, safety, and security of our technology-driven world. To build an EMI-resilient future, we need to adopt best practices throughout the entire design and manufacturing process. This includes considering EMI from the start. Don't wait until you have an interference problem to start thinking about EMI mitigation. Incorporate EMI considerations into the earliest stages of your design process, choosing components and layouts that minimize the potential for interference. Following industry standards. Numerous industry standards and regulations govern EMI emissions and immunity. Familiarize yourself with these standards and design your products to comply with the relevant requirements. Testing. Thorough testing is crucial for identifying and mitigating EMI. Use a combination of simulation tools and real-world testing to ensure that your devices meet the required performance standards and operate reliably in their intended environments. Staying informed. The field of EMI mitigation is constantly evolving, with new techniques and technologies emerging all the time. Stay up to date on the latest advancements and best practices to ensure that your designs remain at the forefront of EMI resilience. By embracing these best practices, we can create a future where our electronic devices coexist harmoniously, free from the disruptive effects of electromagnetic interference. Section 9. Conclusion. Embracing a future free from electromagnetic interference. As we've seen, EMI is an invisible force that can have a significant impact on our increasingly electronic world. But by understanding the principles of EMI mitigation and employing the right techniques, we can tame this electromagnetic beast and ensure the reliable, safe, and secure operation of our electronic devices. From simple passive filters to sophisticated chaotic PWM techniques, engineers have developed a wide range of tools to combat EMI. By carefully considering the specific challenges of each application and choosing the most effective mitigation strategies, we can create a future where EMI is no longer a limiting factor in technological innovation. So the next time you hear static on your radio or experience a dropped Wi-Fi connection, remember that behind the scenes, a constant battle is being waged against the invisible forces of EMI. And thanks to the ingenuity of engineers and the power of science, we're winning that battle, one carefully designed circuit at a time.